Super trees and super crops can be engineered to capture more carbon from the atmosphere. The climate issue is a result of several factors, not just the transition to things like renewable energy and electric automobiles. Another part of it is dealing with the extra CO2 that is already in the atmosphere of the Earth. To meet the goals of the Paris Climate Agreement, it has been predicted that the world may need to remove 10 billion metric tons of carbon dioxide from the atmosphere every year by the middle of the century. By the end of the century, production could reach 20 billion tons annually. Technology with negative emissions has therefore been created. Startups that use direct air capture employ equipment that removes CO2 from the atmosphere, utilizing trees' capacity to act as organic carbon storage systems. A number of entrepreneurs recently raised millions in a Series A round of funding for their companies that restore forests on degraded lands. Other businesses are experimenting with a range of techniques, including growing seaweed, spreading crushed granite on the ground, and regenerative agriculture. Additionally, a business in the Bay Area by the name of Living Carbon is developing plants that can absorb and store more carbon than regular trees. The startup has completed a residency at the famed Combinator Incubator for New Ideas. Without a doubt, planting trees is beneficial. By developing methods to increase both the total amount of carbon dioxide pulled down from photosynthesis and the retention of that carbon, trees' overall drawdown potential can be significantly increased. It can be difficult to find enough land for planting trees without having to compete with other purposes, including agriculture. A forest may be able to help with that issue if it can absorb more carbon than it typically would. What can you do to lower the requirement for planting trees from 1 trillion to 500 billion? You have far more acreage available for different uses. The company plans to reveal more details about the technology later this year. However, it makes use of past research, including years of study on how to enhance photosynthesis in other plants by other scientists. Researchers have been working with a variety of partners to determine whether we can alter photosynthesis for years. It's the result of millions of dollars worth of work over decades of trying to do this in a way that benefits more people than it hurts, with most tests failing due to how difficult it is. You are trying to enhance what nature has been doing on its own for thousands of years. The threat is that the trees may be less resilient to stress and less healthy. The team specializes in tobacco, and via a study has learned that by changing an enzyme in the plant, it may grow up to 40% larger than ordinary tobacco plants. With the world's population expanding, this form of photosynthesis hack might be able to help agricultural crops meet the growing need for food. Through quicker growth, a tree's ability to absorb more CO2 is improved. A second innovation for trees is also being developed by Living Carbon to decrease the rate of decomposition. This innovation will enable trees to absorb copper and nickel, which serve as fungicides. Wood deterioration is accelerated by fungi, which cause CO2 leakage. If the trees were planted widely, they might have an effect. If we could have increased the drawdown capability of those forests by 20% to 30% and increased CO2 retention by a comparable amount, it would have had a considerable impact on the entire quantity that might have been pulled down from managed forests. Improved photosynthesis at a large scale in managed forests has the potential to boost drawdown by gigatons above current levels. The acceptance of the trees developed by Living Carbon may be challenging, as it has been with previous genetically altered plants. They might not be allowed for extensive installation and deployment. The classification of the trees may differ depending on whether they are approved by the Forest Stewardship Council, which prohibits genetically modified trees and forests that it approves as being appropriately maintained. Other advancements, like those that might help trees withstand the current climate crisis, are prevented from being achieved because of persistently widespread misconceptions about genetic engineering. Given the difficulties when the temperature rises, we should assess the ground for heat tolerance in trees. There are several genes that seem of promise for drought resistance that could be tested.